Welcome to Math TV with Professor V. It is Thursday, April 13th, 2023. Here's your integral of the day. Indefinite integral of 1 over the square root of x minus the cube root of x dx. And I'm going to be nice and give you a hint. It's going to require a couple integration techniques, but to start it off, you want to make a u substitution and let u equal the sixth root of x. So if you want to pause the video, give it a try, feel free. I'm going to jump right in. I'm going to rewrite sixth root of x as x to the 1/6. Okay. And then I'm looking here in my integral, I have square root of x and cube root of x. So how can I rewrite those in terms of u? Well, u squared would be x to the 1/6 squared, which remember, when you raise a power to another power, you multiply your exponents. So that's x to the 2/6, which is x to the 1/3. That's cube root of x, guys. And then u cubed would be x to the 1/6 cubed. So that's x to the 3/6, which is x to the 1/2, which is square root of x. So things are looking good because I already know now, okay, square root of x right here, that's u cubed. Cube root of x, that's right here, that's u squared. So the only thing left now is I need to figure out what dx is in terms of u. So come right here. We know u is x to the 1/6. You could get du right now, but it's going to be messy. So what I like to do instead, u is x to the 1/6. Raise both sides to the 6th power. Okay. And then we have, all right, that means u to the 6th is x to the 1st. Now differentiate both sides. So 6u to the 5th du is dx. And that's what I'm going to replace dx with in the integral. All of this. All right? Okay, so let's hop to it. Rewrite our integral in terms of u. So we're going to have now antiderivative. Dx is 6u to the 5th du over square root of x right here is u cubed minus cube root of x is u squared. All right, fabulous. So it looks like we have a rational function now, which we're thinking, let's clean it up and then see, maybe we're going to need to do something, perhaps some division, because I'm noticing the degree of the numerator is higher than the degree of the denominator, right? Okay, so let's take that constant out, and then you have u to the 5th du. I can factor out a u squared from both terms in the denominator, and then I have u minus 1 left. Come through, cancel this u squared. Now we have u cubed in the numerator. So 6 integral u cubed du over u minus 1. So anytime the degree of the numerator is greater than or equal to the degree of the denominator, you need to long divide. Okay, so it's not time for partial fractions or any nonsense like that until the degree of the bottom is greater. So here we go, it's long division time. If you forgot how to long divide polynomials, I will link a video here where I review it. Probably if you don't do it on the regular, it's one of those things you forget. So, you know, I got you a little recap. Okay, take the denominator, that's the divisor, and we're going to divide it into u cubed. There's a bunch of placeholders, right? There's a 0u squared, a 0u, and a constant. You can put them or not. It's up to you. All right. So just think, what do you multiply u by to make it u cubed? U squared. And then you distribute. So this would be u cubed minus u squared, and then you subtract. So this will cancel, and then now I'll have positive u squared, bring down the next term, and then repeat the process. What do you multiply u by to make it u squared? Just a u. Then you distribute that to the divisor. So that's going to be u squared minus u, and then subtract again. This cancels. I'm left with u. Bring down a 0. Keep going. Plus 1. u minus 1, subtract, and positive 1 here is my remainder. How do I know it's my remainder? Because this is degree 0. There's nothing you can multiply u by to make it 1, right? Once the degree here is less than the degree of the divisor, you're done. That's your remainder. So what you do is you take your quotient, which is u squared plus u plus 1, plus your remainder over the divisor. That's the result of the long division. And then I have all of this du integral with the 6. Good? Well, let's look through term by term. I think we're pretty much done. We can anti-differentiate this, no problem. This is just going to be an ln, absolute value of the denominator. So we're ready to go. Let me move this so we can continue working on it right here. Beautiful. Just keep the 6 outside until the end, okay? So we've got 6. Antiderivative of u squared is 1/3 u cubed. Keep it going. 1/2 u squared plus u plus, be careful, ln, absolute value, u minus 1. Close the brackets because the 6 is going to distribute in a moment, plus c. Okay. Now we're almost done. We just got to rewrite everything in terms of x, the original variable. And remember, we had let u equal x to the 1/6. So I'm going to distribute the 6 and replace all the u's simultaneously. So this is going to be 2x to the 1/6 cube plus 3x to the 1/6 squared plus 6x to the 1/6 plus 6 ln absolute value x to the 1/6 minus 1 plus c. And then last step, let's clean up, rewrite everything with radicals. So this is 2. That'll be x to the 3/6, which is 1/2. So that's square root of x plus 3 x to the 1/3, which is cube root of x, plus 6 sixth root of x plus 6 ln absolute value 6th root of x minus 1 plus c. Voila. I love it. Do you? Are you proud? It's a good party trick. Okay, hope you enjoyed the integral of the day. Give it a thumbs up. If you did, subscribe to my channel if you haven't already. Check out my video lecture playlist for Calc 1, 2, 3. And you can also catch me on Instagram and TikTok at Math TV with Professor V. If you want access to exclusive content, extra videos, worksheets, all that good stuff, sign up for my Patreon, link in the description and at the end of this video. Click that little starfishy. All right, have a great one, guys. Talk to you soon.